Marlena gave me this topic, and she said, can you produce about a 25 to 30-minute talk about managing and diverting runoff? Obviously, in the Hawaii area, you are going to be dealing with runoff. You've got steep slopes, you've got a lot of areas that are contributing to your construction site. It can be small areas, it can be large areas. This is a hard topic to talk about in a short amount of time. I can either answer the question of how to do this in a couple easy slides, or I can try and give you more information, but unfortunately it becomes part of a bigger picture. So I'm going to try and do my best to give you that little bit of information, to give you maybe some ideas and some thoughts that maybe you weren't thinking of, that could then lead you down the path to find out what else you can learn about it from other avenues. So let's start going here. The issues with runoff. Obviously, runoff is a major problem for a lot of construction sites because you're dealing with other people's water. And it's coming onto your site, and unfortunately, you have to deal with it. Sometimes that you're lucky enough that the plans are put into place and that the initial design actually takes that into account. And in all honesty, it should. It should talk about the quantity, the type, where it's coming from, is it clean, is it dirty, and what you are going to do on your site. But we're not always that lucky. So I'm going to kind of go through some of these topics and expound upon them a little bit more. So the quantity. Obviously, if you're dealing with a very small amount of runoff, it might be something that you could easily manage. In other cases, you're getting a large amount of runoff that you have to take care of in some form or another. But in all honesty, the quantity, how much, should be determined by a designer. It should be part of those initial phases before any construction actually occurs. And they tell you, okay, we are going to get this amount of runoff, and then they give you the guidelines to actually take care of it. Also, the question I always want to put to designers when we talk about runoff is, what size storm event are you talking about when you figure out that quantity? Are we talking about a 2-year, 24-hour, 25-year, 24-hour, 100-year? All of that is going to determine what type of BMPs you're going to need to either treat it or divert it. So it's a question that needs to be asked prior to any construction, early on in the development of the actual plans themselves. I call it the where and the type question. Where is it coming onto your site? Where's the runoff entering your site, and where is it leaving your site? That may play a big factor in the type of BMPs that you utilize on your site. And then what type is it? Are you trying to collect a whole lot of sheet flow? Are you trying to collect concentrated flows? Is it from urbanized areas? Is it from undeveloped areas? That can lead kind of to that next question that I'm going to put on the next slide. But all of these items, to me, is a designer responsibility and obligation to the site itself. The designer should go through and figure all this out and then come up with the plan. So I'm pushing kind of the design aspect of it, but I know in a lot of cases you get out there to the site, you start working it, and all of a sudden, surprise, we have some runoff. Is it clean or dirty water? And when I say is it clean or dirty water, am I saying is it pollutant laden? And that pollutant can be existing sediment. Maybe it's coming from another development upstream and they're doing very minimal to treat their runoff. Or maybe it has to do with other pollutants like your hydrocarbons. Maybe it was some sort of agricultural land and you're dealing with high nutrients. All of these come into play in terms of how you might end up having to deal with it. And I don't want to get into detail on that because to me that's a whole nother topic of how to treat the specific types of pollutant laden. I can talk about sediment, but some of the other ones I'd rather leave to other individuals to teach about those topics. The question then comes down to, do you divert it or do you accept it? And when I accept it, I mean, are you going to manage it on your site? I always point back to the regulatory officials on this as well. Discuss with them what would be required for your site, especially if it's anything that has to do with hydrocarbons, high nutrient contents, or anything like that. There may be other aspects that need to come into play onto your site. So go back and talk with the regulatory agencies and the designers on how to handle it. So, do you divert it or do you accept it? Diversionary structures. Let's talk about diversion structures. To me, the best way to handle runoff is to divert it. All right, if it's coming through your site, it's going to impact you a lot more. It's going to go over areas that you are trying to work in. It is going to pick up the sediment on your site, And then now you have that much more to deal with. And I'll talk about the management aspect here in a little bit. But to me, the best avenue is to do actual diversion structures. In most cases, you're trying to collect it, and you're trying to collect it with probably something like a berm or a channel. The idea behind it is we're going to collect it up here at the upper part of your project or wherever that run-on comes in, and we're going to try and get it around your project as best we can. So channels or berms are going to be probably your primary friend in this part of the world. But it's going to require stabilization of the channels and embankments themselves, and I'll talk about that here in a moment, some options for that. But you want to do that stabilization because you don't want to contribute more pollutants to that runoff. Because obviously then that means you have to do treatment even though you might be diverting it. So we want to get stabilized channels and berms in place to divert that runoff. Also, it requires stabilization at the discharge point. So wherever that run-on is going to discharge off your property, we need to ensure that there is a velocity dissipation device, a way to prevent erosion from occurring at that spot itself. But the primary goal is to collect and control the flow of water. That's all you're trying to do here and minimize the potential of erosion. When I say potential of erosion, what I'm saying is the potential of erosion on your site through the channels and diversions. It may require formal design to convey the flows. If you're getting a small amount of run-on, we may be able to just go out there and take a piece of machinery and dig a ditch, kind of create a small burn, and you're able to handle it. When you start getting the larger flows, definitely have a designer step in and help you with the sizing of the channel, because you do not want those to fail and come up onto your site itself. Slope drains. I look at these as two different types, either the basin or the roadway. And the reason I separate them is if you are a designer or you go down that path, there are different calculations to use whether or not you're using a basin slope drain or a roadway slope drain. So talking about the basin slope drain, basically what we're talking about is we're collecting large amounts of runoff at some point and conveying it safely through a pipe system to a downstream location. These pipes tend to be a lot larger because they do carry the larger quantities of runoff. The thing is, though, at the very top, you need some sort of form of containment. You need to collect that runoff at some point, whether it's sheet flow, whether it's concentrated. In many cases, we have an earthen berm with some sort of protected inlet at the pipe itself so that we don't have the damage occur and a blowout happen at that spot, because that's going to be the most sensitive area. We need the anchoring of the pipe itself. It's amazing how much the hydraulic pressure in these pipes can cause the structure to actually move across the hillside itself. So we look at the anchoring. And then we need a controlled and stabilized discharge. That was true for the berm, the diversion ditches and berms. It's true for your slope drains as well. And because otherwise we end up with a scouring and that erosion at the discharge end of the pipe. The roadway slope drain is it's the same idea, but it's a little bit different in that we are typically dealing with smaller flows. And in many cases, we are dealing with multiple pipes versus a basin where we oftentimes have just one large one. Slope drains, we tend to use a number of them along the roadway itself, and it's just to collect the runoff more frequently and take it down to a lower location. The big part of it, just like the basin, but with the roadway, it's very critical as well, is the entryway into the pipe itself. It can be collected in a number of different ways, but oftentimes we're more limited because we are dealing with runoff off of a roadway. We can't have a large structure there that could be impacting either construction or possibly existing traffic if we're trying to collect something off of an existing roadway. So oftentimes these are smaller structures, but it's very critical that they are looked at and designed properly to handle the flows themselves. And then obviously the control at the discharge, you kind of notice a theme, if you will. The collection point and then the discharge points are big on slope drains. This one I put out here because I've seen sites where the contractor has gone out and tried to throw just pipes at the problem and said, well, I'll just try and collect the runoff with this pipe because I had it on my site, and it failed, and it failed, and it failed. It is something that requires a proper design. It requires the proper sizing of the pipe, and also if you are dealing with a roadway, it may be the spacing of the pipes as well, how many you will need and how far apart they are actually spaced. So I push this back and say, find somebody who can do the design itself. Don't just throw the pipes at the problem. You may be fine, but in many cases you are not. So, do you divert it or you accept it? Talked about the diversion aspect of it. Now let's talk about accepting it. Obviously, when we talk about accepting it, we're now talking about, the channel stabilization. Take one big step back there. Let's talk about the channel stabilization for the diversion. I apologize for that. I moved these around on myself last night, so I forgot that I pushed these forward a little bit. Channel stabilization. I mentioned in it when I was talking about the channel berm and the channel ditches themselves that stabilization is a big key in it. When you're dealing with slope drains, you're lucky because the only places you have to worry about is the entrance and the exit. With the berms and the channels themselves, we need to make sure that we're not adding to the problem itself. And one simple way, I know a lot of contractors and designers do this, is with check structures. Because it's easy to get a wattle or a pile of rocks and go out and throw it in the ditch itself and say, look, we're going to be able to control erosion this way. There's a lot more to it than that. The idea behind a check structure is to reduce the flow of velocity in the channel itself. And I'll show you a nice little detail here to kind of give you a little bit more of an explanation as to why that's important. But what basically it does is it creates a small pond directly upstream of the check structure itself, and that helps slow down the velocity, and it also allows for any materials to possibly fall out of suspension, so it's working in two different ways. It does require proper design and installation. You notice how I keep going back to design? I'm really trying to pull the designers back into this because to me, this is where we have the problems on the site. But it requires proper design and the installation. The biggest problem I see on construction sites when I go out there and I see check structures, incorrect installation. 95% of it is incorrect installation. So if you deal a lot with check structures, maybe take a big look at them and determine whether or not they're actually working and working correctly or will work and function properly. And the big point where they don't function is because we are lacking a low point for discharges. What ends up happening is if we don't have that low point is as the runoff comes down through the channel itself and it can't go over a low point in the structure, which this actually shows a very nice picture of it, it will start going around the sides and eating away at the embankments, which can cause a potential failure of the structure, of the whole structure, the channel itself. And it also can add to the sediment that's in the water. So now we are creating that additional problem of introducing sediment into the run-on waters. It is a very high maintenance item. To me, check structures are overly used and not maintained as often as they probably should be. Not just from the lack of proper installation, but just the lack of continual maintenance to keep these functioning. Because depending on the type of material you use, they can fail just over time from the wear and tear on them. So they are a high maintenance item. This is the typical detail that I was talking about that kind of gives you the reason behind why I say there needs to be a proper design for this, that you just can't go and throw structures into a channel and expect them to work. If we're using these for erosion, what you're trying to create is that little plateau there to slow down the water. But by slowing down the water, we give a place for the sediment to settle out of suspension, and that way we're not adding to the problem itself. But in order to achieve that, the spacing is absolutely critical between these check structures. You can do a quick check out in the field and make sure that the top of the lower structure is lower than the bottom point of the next one up. But in all honesty, it actually comes down to a design calculation. Every channel obviously is going to be a little bit different, and it's going to come into play with the channel slope itself. And this, I threw it up here because this just points out that you can't just space these every 100 feet or every 50 feet. It doesn't matter what channel you have. You need to base it on the channel slope itself. And I'll just throw this at you. Say you have a channel slope that is about 2%, so not a very steep channel at all. And you're looking at throwing a check structure in there that's about 18 inches in height. So it could be a rock check structure. It could be a wattle check structure. It could be even a reinforced silt fence, which I'm very hesitant to even bring that up, but I've seen it happen. In that case, you would end up spacing these structures at about 75 feet apart. So a good distance apart. We don't have to use as many check structures, but the channel is shallow. It's only 2%. Let's now kind of take a look at one other option. Let's go up to 6%. All right, so we're starting to get a little more steepness on it. At that point, you use that same type of BMP, that 18-inch high BMP. Now we're looking at something that's, what, about 22 feet apart? All of a sudden, our costs just went up dramatically. We have a lot more BMPs we have to put in the channel, or check structures we have to put in the channel, and now we have to do a lot more maintenance, a lot more inspection. So it's not just the installation of the BMP, it's the maintenance and the long-term functionality of it. But I just wanted to throw that out there because I know check structures are a big one. I see them across the nation. I see them across the world when I've traveled and looked at construction sites. So it's something that's common to a lot of locales. I'm going to throw a different thought at you that I know a lot of people might grimace on because they're calculating the initial cost in it, but it actually works probably a lot better. Check structures, they work good if you do them right, you design it right, you install it right, you maintain it correctly. They can work and work just fine. Let's talk about instead rolled erosion control products. And I look at it in two different ways. Erosion control blankets, which to me are a temporary material. It means they're going to degrade a lot quicker over time. And it's not meant to be a permanent structure. So the ditch is going to be in there for maybe it's a couple months. This might be something that would work out very well. However, because it's a material, it's not as robust, it's not going to handle the higher shear stresses. And yep, there I go again. You need to talk to a designer. Sometimes you can throw something in for a quick fix, but I would say go back to the designer and make sure what you put in is going to work. Because if you have higher shear stresses coming in with the run-on, it's going to destroy this blanket. And it's not the blanket that failed, it was the incorrect design, incorrect choice of material. But this, to me, it might work with smaller amounts. The channels aren't as steep. It could work fine. It is a cheaper product than something like a turf reinforcement mat. To me, a turf reinforcement mat is obviously a more permanent structure, but I look at it as a more robust structure as well. It can handle those higher shear stresses within the channel. So maybe we have a large watershed that's coming onto the site. This is something that may be able to handle it, even though it might be just a temporary structure at that. Again, though, I look at it and say I really encourage people to go back to the proper design because there is correct ways to determine what type of blanket material, whether it's the turf reinforcement mat or the erosion control blanket, that is needed. Now, management. Here we go. Now I talk about the management. Say you look at your site. You're out there and you say, well, we didn't have an initial design on it, and there is no way for us to put in a diversionary structure. For whatever reason, it is not going to happen on our site. Maybe your site you're having to disturb all of it and work in all areas, so there's no place to actually construct one of these. Maybe it's just due to the location that the run-on is coming in on and where it would have to discharge. It's just not feasible to try and create such a structure. Well, in that case, I look at it as more of a management issue. And it's a management issue for you as the contractor to deal with, but I also say it's a management issue that the designer should have taken into account as well. Because unfortunately what I end up seeing is we have run-on coming onto the site, and it's the expectation that the BMPs that were designed for that site to handle just your site itself, the flows on your site, are expected to take that extra amount of water and actually deal with it. So I look at it and say, no, we need to probably have additional thought put into the existing BMPs. So if you can't divert it, you're going to have to manage it. So what normally happens, it's going to mean you're going to have to implement or increase the amount of BMPs specified in the SWIP to accommodate the increase in flows. All right, so maybe it means that you have to have additional silt fence barriers. Maybe it means you actually have to create sediment traps where you weren't looking at having a sediment trap before. The other issue that you deal with management is if you have dirty water coming onto your site, you get to treat it. Sediment laden, you get to treat it. The hydrocarbons, you get to treat it. So it's not just I can't, it's not my water. It's coming off of another site. I'm sorry, it's now yours. and you get all the headaches that go with it. It's why I do encourage the diversion if at all possible. So, increase the number of BMPs to handle the flows. And it may not be just to increase the number, it may be increasing the size of it. Downstream sediment control structures, you have that one row of silt fence. Maybe one row is not going to be enough anymore. Maybe we actually have to have a couple rows. Maybe we have to create, like I said, those smaller sediment traps, or maybe we have to increase the size of a sediment basin. Maybe it's not just increase the size, maybe it's increase the amount of maintenance. So you have individuals going in, maintaining these BMPs a lot more frequently, removing extra material because you know that there's added sediment or pollutants that are coming to the site itself. So traps and basins, increase the number or possibly also increase the volume in it as well. But absolutely, this is probably going to be a given as your BMPs are going to require more frequent maintenance. I feel for you guys if you do have to manage it, because to me it's not fair to have to manage somebody else's run-on, especially if it's pollutant laden. But unfortunately, it's a fact of life itself, and it's what you end up dealing with. The big one, though, is going to be the cost. There has to be a mindset that no matter what you do, you're going to have an increase in cost dealing with run-on, whether or not it's through the diversion structure or more with the management. Like I said, increase in maintenance, increase in number, increase in size, increase in types of BMPs, all right? Is controlling run-on easy? Well, requires a proper design, proper installation, maintenance of BMPs, may require additional BMP design and installation, and most important, though, is communication and accountability. And I throw that one in there because to me this is something that should be occurring on all construction sites no matter what's going on. It doesn't matter if you have a problem or not. Communication and accountability between all the different representatives, whether you're regulatory, whether you are from the design world, whether you are an inspector, whether you are the contractor, maybe you are a subcontractor. Communication is key, and accountability. You are now accountable for that run-on, whether or not you divert it or you do management on it. So there's no one easy answer. And I know when Marlena throws these topics at us, because we've taught these for a number of years here at the DOT conference, she always throws different topics at us, and it's like, can you talk about this in 25 minutes? And I say, well, either I try and just give them the brief hit upon it, and then you guys go and find out more information. That's the best I can do. So I'm actually, yeah, I do. We have about 5 minutes. Do you guys have questions?